Hi, and welcome to our set of notes where we're going to review basic chemistry before we get into some biochemistry. So in this section of notes, we're going to go over elements and atoms. In a later section of note, we're going to talk about bonding, and then in another section, we're going to get into specifically talking about the water molecule and why it's so important for living things. So, just as a reminder for you, matter is anything that has mass and takes up space. And so this is important because all living things are made out of matter. So the question then becomes, well, what is matter made up of? Matter is made up of elements, which are the simplest pure substances that we can have in existence. The thing about elements is you can't break them down into other substances. So carbon atom is a carbon atom. It can't be broken down into anything else. Elements are often called the building blocks of matter because matter is always made up of one or more elements. Potentially it could be one element, or it could be two or more elements that are combined together in a specific way. So atoms make up an element. Individual atoms are the smallest particle of an element. So this is a common drawing of an element. In the nucleus of the element, which is here, we have protons, and protons have a positive charge on them. And we have neutrons, which have a neutral charge on them. A lot of times we'll abbreviate neutral, or I'll abbreviate neutral as a zero with a line through it, meaning that there's no charge on that atom, or on that subatomic particle, rather. Outside the atom, or outside the nucleus, you have electrons flying around. Electrons have a negative charge on them. And so when we look at this image, we can count the number of positives, 1, 2, 3, 4, 5, 6. So in this particular element, we have 6 positive charges, and then we start counting our negative charges, 1, 2, 3, 4, 5, 6. And we notice we have 6 negative charges. So the thing is, the 6 positive charges equal the 6 negative charges. So this atom overall is neutral. There's no charge on this atom. If, however, I lose an electron, I take my electron away, now I have one more proton than I do electron, and so now I have an extra positive charge, so this would be a positively charged atom. I can't take away any protons because that would actually change what the atom is. But if I add an extra electron in here, now I have 7 electrons and 6 positive charges. And so my atom is now going to have a negative charge on it. The ability for atoms to lose and gain electrons is going to be important when we start talking about bonding. So atoms are neutral, like we said on the last screen. The number of protons is always going to equal the number of electrons. Charged particles can be either positive or negative. They're going to be positive if they have more protons than electrons. They're going to be negative if they have more electrons than protons. So a carbon atom has 6 protons and 6 neutrons. So my question to you then is, if a carbon atom is neutral, how many electrons does it have? Take a second, answer this in Edpuzzle. So you probably in middle school learned about all the different types of atoms and elements that we have. So a lot of you are probably sitting there saying to yourself, well, which atoms do we actually have to know? For biology, you don't have to know all of them, don't worry. The most important ones are carbon, oxygen, hydrogen, nitrogen, phosphorus, and sulfur. I usually abbreviate this as CHNOPS. CHNOPS, 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 CHNOPS. These are the ones that you really need to know about them. Others are needed for organisms as well, but these are the big 6 that you really want to make sure that you're aware of. So in our atomic structure, where we have the nucleus in the center, right? We have our nucleus in the center with our protons and our electrons. Then we've got our electrons in the outside, okay? The electrons that are in the outside shell are what are called valence electrons. So valence electrons are going to have your highest energy level. So this one little electron I drew out here is in its valence shell. This is going to have a lot of energy, and it's going to be held the most loose in comparison to these two. These 2 electrons are going to be held real tight into that nucleus, but this one is not quite as tight. How many electrons we have in the valence shell, or valence electrons we have, determines the property of that element, how it can bond with other atoms. So a lot of times what I'll use for drawing electrons is what's called a Lewis dot diagram. Lewis dot diagrams just show the valence electrons that are necessary for bonding. So let me show you an example. So let's say I want to talk about the element carbon. Carbon has 6 protons and 6 neutrons in it. So we got 6 positives, we got 6 neutrals. If we have 6 positives, we have to have 6 negatives in it. So we have 6 electrons. So a Lewis dot diagram, so if I draw a carbon atom, I'm going to have 6 protons on the inside. I'm going to have 6 neutrons on the inside. Around it, I'm going to have my electron shells. So I'm going to have 2 electrons in the first shell. That's all that first shell can hold. In my second shell, right, I've got 6 electrons total. I got 2 right here. So 6 minus 2 is 4, which means in my second shell, I'm going to put 4 electrons around my nucleus. Now, as a biologist, I really don't care about these 2 electrons on the inside. I only care about these outside ones. And so I don't really need to draw all of this inside stuff. I just need to focus on this outside. So to do this, to make my life easier, I use what are called Lewis dot diagrams. So a Lewis dot diagram is going to have the symbol in the center, and then you're going to draw the dots in a circle around, or actually technically it's a square, around the symbol element. So what this shows is that in my outside shell, I have 4 electrons in carbon that are available for bonding. If I was dealing with, say, nitrogen, nitrogen actually has 5 electrons in its outside shell. So I would write my N for nitrogen. I would have my 4 electrons around, like I did with my carbon, and then I'd have my 5th electron I'd put right next to one of my 4. Okay? So this is how we draw Lewis dot diagrams. I'm not looking for you to draw out full diagrams like this all the time. Use the Lewis dot diagrams. They're much easier to work with when we're looking at bonding. Most atoms are more stable, meaning that they're less likely to react, if they have a full outside shell. Atoms that naturally have the full outside shell are very unreactive. These are what are called your noble gases. They don't form compounds easily with other atoms. But most atoms are not full outside shells naturally, and that's why they're going to form bonds. They're forming bonds to become more stable and fill up their outside shell. So in our next set of notes, we're going to talk about how bonding works that we care about for biology. As always, if you have any questions, please write them down, and when we go over this in class, please feel free to ask.